Today in my workshop I was working on some drill batteries. This one is a lithium ion drill battery from Ryobi. The first problem I encountered when trying to harvest the cells from it, the lithium ion cells, was that the screws in the bottom were safety torques and I didn't happen to have that bit. It's late at this time and I didn't want to go out to the hardware store tomorrow, so I decided I would drill out the screws. This is a simple solution to a problem, whether it's a screwdriver bit that you don't have, or perhaps the bit has been stripped and the screw can't be unscrewed with a screwdriver, then drilling out the screw may be the only solution to opening the casing. It's a labor-intensive process and I used a lot of WD-40, and eventually I was able to drill into the casing where I was able to open it and pull the cells out. Now I'm taking it over to my bandsaw where I'm carefully cutting the casing. I cut a little tiny bit from the edge and make sure that I haven't cut into the cells yet. And I take a flashlight and I look inside to see what I can cut out next, until I can cut more and more and more, until I finally figure out that I'm able to cut a section off that will allow me to open up the case. I wouldn't recommend this method. The bandsaw could easily cut through one of the lithium cells and short it, which would cause it to catch fire. But if you're very careful and pick the right spots, I picked the front of the drill battery because it's rounded and I knew that the cells wouldn't fit into the little tiny section I was cutting through. Here I am ripping some parts off. The cells inside should consist of a series pack of 5 lithium-ion 18650 cells. 18650 cells are the most basic lithium-ion battery you can get. You can see a little stack of blue ones right up next to my vise. They're quite easy to use, quite powerful, and can be a little bit dangerous. Lithium-ion cells are used in drill batteries, they're used in laptop batteries, and they can deliver quite a lot of current. It may seem tedious to watch a drill battery casing tear down, but this is actually an incredibly useful skill to learn, how to pull apart things that are made of plastic, especially when the screws in them are hard to remove or perhaps hidden, how to get into things when people don't want you to get into them. The same cells that are found in this drill battery can also be found inside of laptop batteries, and I'll have a teardown of one of those soon as well. They can both be used relatively interchangeable for all kinds of different projects. The major difference between a laptop battery and a drill battery is that the laptop battery is often wired for lower voltage, so that means more cells in parallel and less in series. Now I'm drilling holes in the plastic surrounding where the screws are held in. This allows me to carefully cut a way around the screws so that the screws are holding on to nothing, and the casing can easily be pried apart. Here I've finally gotten the cells out of the casing, and I'm checking the voltage on the terminals themselves. They're able to just turn over the motor, but I'd like access to the raw cells themselves. So what I'm going to do is I'm going to cut off the leads that go to the circuit board. It's relatively easy to do. The nickel-plated strips that are used to hold the lithium cells together and to connect to the board are quite easy to cut with wire cutters, so I'm just going in and tearing them to release the cells from the rest of the board. There are a number of useful components in drill battery packs, particularly lithium-ion ones. Lithium-ion ones tend to be protected by a protection circuit, which means that they have some quite strong MOSFETs. MOSFETs are transistors that are rated for a lot of power, or another way to think of them is a light switch that's turned on and off by more electric current. They're really useful in electronics projects, and for high-power applications, the MOSFETs in drill battery controllers are really good. There's also a significant heat sink on this particular model, of course the cells themselves, and I'm also going to keep the stock of the drill itself, because with that I could connect easily to a Ryobi drill if I ever wanted to in the future. Now I'm taping up the battery cells and making sure that they're still well and connected, and then I'm going to take them over to my variable bench power supply. This pack has 5 cells in it, all in series. Each cell has 4.2 volts in it, so 4.2 times 5 would give us roughly a max voltage of around 21. I'm going to err on the side of caution and charge it to 20 volts. So I set my lab bench power supply to 20 volts, and I'll measure the voltage on the battery. And now I'll measure the voltage on the battery, not to measure its level, but to measure its polarity, so that I can test and decide which leads to place where. Each cell can take 1 amp of charging current. In a series configuration, those amperages are the same, so 1 amp can go across the entire pack. However, if you had all 5 of these batteries in parallel, they could take 5 amps of charging current, because they have 6 more pathways for that current. Now I'll set the current limit on my power supply to roughly 750 milliamps. If you find that your cells do not charge properly in series, it may be that one of your cells is dead or needs recovery. If you don't want to attempt to recover the whole pack, you can easily cut them apart like this. I use a pair of needle nose pliers, a small pair of needle nose pliers, to rip the nickel strip off, and you can free the cells that way. Here are all the components I salvaged in the end. 5 lithium-ion cells, a heatsink, the drill battery stock, several screws that will be useful in the future, and 2 MOSFETs. Thanks for watching.